Good morning. We were discussing about the service experience of all the three technologies, ceramic, glass and polymer insulators in the field over a period of the installations. So, one of the important criteria for the insulator to function in the conditions like polluted or contaminated conditions, and this is a very important aspect for the insulation to perform for both the flashover and also the withstand conditions. So, these insulators are designed, or the line insulation as mentioned earlier, I am repeating the slide here. The factors which determine the insulation above 220 kV is the lightning and switching surges. Above 400 kV is the switching surges, and contamination or a pollution plays an important role for the line design. Further to 765 kV level, contamination or pollution is the utmost important criteria for the line design, very important factor to be considered. So, keeping this in view, the insulation could be of ceramic, glass or a polymer, has to perform in the field for the contamination or a pollution conditions. So, what is this contamination or a pollution affecting the performance? The important factor to be noted is during the contamination or a pollution condition, it is not the over voltages which causes the flashover, it is at the normal working stresses. So, this point I have earlier mentioned. So, the any reliability of the power system transmission network, it could be in extra high voltage or ultra high voltage, this is very seriously affected, and the literature and also the performance of the line not only elsewhere in the country, we have seen several outages because of the pollution induced flashover which have occurred at the normal operating voltage. So, normal operating voltage, I mean the working voltages of the system, it could be 220 kV, 400 or the 765 kV system. So, there is no over voltages, the phenomena occurs at the normal operating or working voltages. You can see the graph here. By seeing the graph, this shows the flashover voltage in peak versus the time of flashover. So, the example cited here is the 220 kV system, where 220 kV operating system, you see the 206 is the maximum operating voltage and 186 is the minimum operating voltage for a 220 or 230 kV operating system. When you carefully look into this, the impulse withstand, there is a lightning impulse withstand for a 220 kV system for wet and dry conditions is value somewhere 1275 to 1265 is the lightning impulse which is being applied, and insulation is tested. So, the performance for 220 kV, the lightning impulse of 1.2 microsecond by 50 microsecond tail, front and tail impulse is applied and verified for the insulation strength. So, similarly for a switching surge which has a waveform of 250 by 2500 microseconds. Here a switching surge magnitude is typically around 875 to 765 for dry conditions or wet conditions, the figures are shown here. So, switching surges or lightning surges both for dry and wet conditions, the insulation withstands in the laboratory or in the field, but when you carefully look other than the clean conditions, you can see the curve here. This curve over a period of time, this is the time axis which I showed, the time to flash over the time axis here. Over a period of time, this curve touches the operating voltage line here. This shows that the insulator in the field over a period of time, the pollutants got collected. After this, because of dew or a light rain or a mist, the insulator when it comes in contact becomes wet and the surface starts conducting. Once the surface starts conducting, depending upon the layer of pollution formed and the conductivity on the surface, this discharges could start, which are known as scintillations or partial arcs on the surface. Depending upon the surface conditions, the insulator, entire insulator, there could be a flow of leakage current and the flash shower across a single disc. A further cascading effect could also be seen, where the entire disc insulator or the entire string insulator could flash over and the tripping of the network would happen. So, here it is very clear. So, the pollution levels could happen, or a pollution flashovers could happen at the normal working voltages. So, a very important point, shows the threat of flashover which could happen for a glass or a porcelain insulators at normal working conditions, serious threat. So, for EHV and UHV, or both for AC and DC, the pollution phenomena has to be considered while going in for the line design. Now, pollution, what type of pollution? Pollution could be of several types and nature of the pollutants. In case of the lines, transmission lines passing near the sea coast, the salts from the sea could be collected on the surface of the insulator. So, because of the this type of pollution or the salt spray which has been observed near the marine or the sea coast or the areas where the rivers transmission towers are near to that, and the salts get deposited over a period of time and becomes conductive because of humidity, temperature, low temperature or fog or mist, or because of the rain conditions, and the flash shower could happen. Similarly, the pollution could be of industrial pollutants. The industrial pollutants, again it could be the transmission lines passing nearby the industries. Industry could be again example of a cement industry, or it could be any chemical industry, or it could be the large brick kilns, where these pollutants from these industries could go and collect over a period of time on the surface, and later on after becoming wet could cause a flash shower. The third being the desert pollutants. Again, desert pollutants, here the transmission lines which are in the desert areas are seen that the desert, because of the high winds which are seen, the sand from the desert goes and collects on the surface of the insulator. Sometimes the sand is of contains very high salty conditions. So, this over a period of time, because of the humidity, the surface could conduct and there could be a flash shower. The mixed pollutants could be the lines which are passing near the sea coast, and the industries are also situated. So, any 2 or 3 combination of the pollutants could cause this mixed pollutants, or the lines which are passing near the industry and some of the areas, agriculture activities, so on and so forth. The third, the other pollutants could be of the agriculture activities. These agriculture activities, particularly during the season where the fertilizer spray or because of the agriculture activities, the pollutants go and settle on the surface. This could be the pesticide spray, could be because of the low flying helicopters which they use for the fields to spray. This could cause the surface contaminant over a period of time. Similarly, in the transmission lines which are near the cold countries or in the places of high altitude, where experience of a very low temperature, fog, snow, ice accumulation over a period. So, you can see here one of the typical example of that, the collection of the fog or ice collected on the transmission system. So, this again the insulators completely are covered with the ice, and here the pollutant this could cause a flash over. So, lot of maintenance is essential for the overhead transmission lines, particularly during these conditions, to remove the pollutants on the insulator surface. Apart from this, you have growth of vegetation. The transmission lines could be passing this vegetation will conduct during the wind conditions. So, regular maintenance of the transmission conductors, minimum distances have to be maintained, else there could be a short circuit or the flash over because of the vegetation or branches coming in contact with the transmission conductors. So, these are some of the examples of the pollution could be of near the cement industry, or because of the salt spray near the sea coast, where because of the marine transmission lines near the sea coast. So, these are various examples of the contaminants. These collect over a period of time and becomes wet, and the flash over could happen. The example shown here is because of the bird droppings or the bird excretion during the flight from the transmission tower. This excretion of the bird is a highly conductive fluid, where the fluid could come in contact with the phase conductors, and the flash over could also happen. So, how the phenomena of pollution flash over happens, I have briefly informed about this. So, a repetition of the phenomena here. So, as mentioned in the towers, the insulators, the conductors are there in the overhead transmission system. The pollutants could be of marine or the sea salts, or could be the industrial pollutants, or the agriculture activity related pollutants, or because of the other activities settle over a period of time, and this settlement of the pollutants will be non-uniform, or because the wind could carry some of the pollutants, or the pollutants settle at a different uniformity on the surface, because this over a period of time, in case or before the monsoon starts, there could be a wetting because of the fog, rain, drizzle or snow which is on surface, and once the surface becomes wet, the surface starts conducting. So, the flow of leakage current happens. The flow of leakage current again here depends upon the pollutants sprayed on the surface. So, in case the pollutants are uniform or not uniform, then because of the wind, some of the pollutants could be more at some locations and some could be very less, and in some places there could be no pollutants also. So, here because of this flow of leakage current, there could be non-uniform heat generation because of the arcing there, and further non-uniform drying. So, both here on the surface, the formation of small bands which is dry and wet in nature could be observed. So, the formation of these bands, dry band and wet band on the surface, could create non-uniform conditions, and the arcing particularly across the dry band is observed. So, semi dry band or dry band arcing is seen, where inception of scintillation or partial arcs, what we call. So, these scintillations or partial arcs which happen could elongate depending upon the surface conditions. So, and in case the entire surface becomes conducting, there could be a flash over of a single disk initially, and further the cascading effect or the redistribution of the entire potential across the string takes place, and there could be a complete flash over of the entire string. So, here a very important point to be noted is the scintillations usually start from the high voltage conductor, zone high voltage field, that is near the pin junction. So, this we will be looking into that. So, the region around the pin, the stress is very high here, and the field is higher in this, where scintillations start from this pin region and further travel towards the petticoats and could bridge to the cap of the insulator. So, this is again a schematic of how the pollution deposits, the wetting which happens because of the rain, fog or the mist or snow, The discharges you can see here, discharges could happen, partial discharges or scintillation, small arcing, dry band arcing or wet, where formation of dry and wet band take place and the small arcings happen. So, further depending upon the surface conditions I mentioned, there could be flashover of a single disc and entire voltage redistribution could take place, and the flashover could happen for the across the entire insulator string. So, this is one of the laboratory experiments which has been performed in the lab. You can see as the stress voltage level is increased, the polluted insulator string, this is in case of a 3 discs here. You can see the discharges developing here near the pin junction. This is the high voltage conductor. So, other side being the conductor connected to the tower, that is a earthed conductor. You can see the initially scintillations or a partial arcs which start near the pin junction, spread towards the petticoat slowly, and as the voltage level is increased further, depending upon the surface conditions, you see here the discharges, the scintillations initially, then the discharges will be higher and a bridging could happen like this. Once the bridging happens across a single disc, then the entire voltage redistribution takes place and the entire string could flash out. So, this happens, similar phenomena happens in the field, and as I mentioned earlier, exact time it depends on the pollutants which are collected on the surface, and the phenomena could take time, and this entire phenomena could happen for the normal working voltage conditions. So, that is a point to be noted. So, how to contain this, or how to see that pollution or a contamination flashover, to understand in a better way, and how to tackle this problem is very important, particularly in extra high voltage and ultra high voltage ranges. So, pollution or a contamination phenomena is a very complex, as I mentioned, and theoretically it is very difficult to comprehend this phenomena. So, considering all the parameters, simulating these conditions or deriving these conditions is a very difficult task, as the phenomena is dynamic, depends on several of the parameters. So, very difficult to theoretically come to a conclusion and arrive that solving this problem could happen. Second, as I mentioned, this phenomena is a time very slow electrothermal process. So, it involves not only electrical process, it involves the heating of the surface layer, formation of dry bands, wet bands. So, it could take period could extend a very large time, or depending upon the surface condition. So, similarly, the experimentation in the lab or exact simulation in the lab is equally difficult. So, theoretically is also difficult, experimentation, simulation, exact conditions is also equally difficult. So, what are the parameters which are influencing this? As mentioned earlier, the wetting rate. So, how, whether it is a rain, fog, mist or due to humidity conditions. So, how much is the wetting happening on the surface and how the conduction is happening. So, it is very difficult to exactly point out, as the surface of the condition of the insulator in the field varies dynamically because of the wind and several other factors. So, pollution, what type of pollutants are spread on the surface, it could be industrial waste, it could be chemical wafers, it could be the salts which are spread, or it could be the sand, it could be any other pollutants like the ash deposits, so on and so. So, the influencing parameters along with these pollutants depends on the wind and its direction. So, the wind and direction will also play a major role. The wind could carry the pollution away sometimes, or sometimes it accumulates the pollution to the existing thing. The type of insulator. So, what type of insulator is being employed for that particular location. So, several of these parameters play a role in the contamination issue or contamination or a pollution flash or phenomena. So, apart from this, it is not there are methods which are not been this phenomena is very well understood, but the methods which are available in the literature and which are practiced by the utilities in tackling this, there are some remedial measures suggested by the various working groups, and several utilities do follow, and they have tried several methods to overcome this phenomena. Some of the examples could be the coatings on the surface of the insulator to avoid the pollutants getting collected on the surface. So, applying the silicon grease, again silicon grease, making it hydrophobic where water droplets or the pollutant should not accumulate on that. Going in for RTV coatings, that is a room temperature vulcanized. RTV is room temperature vulcanized coatings which are normally done on ceramic insulators to see that this coatings will help in prevention of the pollutants getting collected on the surface. Similarly, resistive glaze, this is basically a glaze coating on the surface to make uniform conduction on the surface, has been tried out by the utilities. Several literature do exist on this. So, people from the utilities have also tried using the creepage length, that is increasing the creepage length. So, increasing the creepage length, sometimes additional insulators have been tried out, or sometimes the new type of insulators have been tried out. One of the example could be the bell type of arrangement, or going in for the special creepage extenders. You can see here the extender portion of the insulator is intentionally done to see that extra creepage is being provided for the insulators to overcome this. Live line washing. So, there are methods which are being employed by the utilities, not only in several countries, in our own country. The utilities employ the high telescopic type of arrangement with a special nozzles to clean the insulators before the monsoon conditions, and there are live line methods where live line methods are being adopted for the insulator cleaning. This could be the water jets from the telescopic boom ladder which is mounted on the trucks, or through live line washing methods where this phenomena is being carried out. Recently there is also where it is very difficult to see the truck goes, particularly the transmission towers which are on the high altitude range or on the mountainous area where it is very difficult to go. In such places helicopter mounted nozzles with a special arrangements are also being used to clean the insulators during the monsoon conditions and see that the flashover is contained. So, several of these measures are being tried out, and most of the methods are being used for cleaning of the insulators. Lot of maintenance is being lot of maintenance, personal and also the economy is to be is being used for this phenomena. So, again this slide shows how the methods are being used. One of the method is again the water jet on the transmission systems, earlier like earlier like the was shown using helicopters or lorry truck mounted nozzle type. Here also washing of the insulator is one of the phenomena which people are trying to see to improve the conditions. Adding more bells, I mentioned this. This is simply to see that increasing the creepage of the existing insulator where this could help to contain the contamination. Dry cleaning with high power jets, that is cleaning without the water in some of the utilities are also being used. Then as mentioned RTV coatings, again RTV coatings, it is a coating to see that the surface of the insulator becomes hydrophobic and does not allow the contaminants to settle on the surface. So, several methods are being employed in the field by the utilities as this phenomena at monsoon conditions is threat to the normal working conditions. So, these are some of the examples using with a low pressure spray gun for the cleaning purpose. Then as mentioned the RTV coatings for various insulators, it could be post insulator, it could be application of the bushings, wall bushings. So, lot of effort has been made into that. Then as mentioned extending the creepage. So, there is again arrangement where to see that the bird shielding particularly to contain the bird droppings on the insulator surface and its performance should be improved. So, there several methods have been suggested for this practically to improve the pollution condition. Then creepage extenders, as I told. So, some of the sheds are increased with the help of creepage extenders, so that the creepage length is increased and this will help in the polluted condition. Several methods have been tried, a few are being used by the utilities regularly. So, in case of the ice accumulation, a lot of effort has to be made to clean up the ice loadings on the insulator and the conductors during the winter conditions. This causes lot of revenue loss for the utilities. This is one of the again example of the telescope boom insulator cleaning method used by few utilities. This is the live line washing method. These are again the truck mounted helipad where it is being used for the cleaning of the insulators. So, we have looked out into the several options of improving the pollution conditions. Some of them are being practiced by the utilities, but there is a need, still there is a need to develop suitable mitigation technique which could be cost effective. All the methods suggested in the literature and also being practiced are being highly costly, and also the performance is to be a lot of maintenance personals are also required for the cleaning and so on. So, there is a need to develop suitable technique which should be cost effective and also gives a better performance in the field for the utility. So, with this in mind, the institute at the department has tried to look into this problem seriously, and there was an effort to come up a suitable method for reducing the flashover conditions and see that insulator withstands for higher voltages than the normal conditions which it used to happen. So, the main intention was to see that and enhance the pollution flashover strength particularly by reducing the maximum surface field as mentioned near the pin junction. So, surface field near the pin junction is where the conductor gets the high voltage conductor is connected and this is connected to the tower. So, this junction is the critical junction where the field is high and this field has to be reduced, so that the scintillations or the partial arcs which occur from this junction is reduced. So, with this information some solution was thought and how it could be done. This should be done again without disturbing the normal extension, the conditions of the pin cap and the insulator which is fixed. So, without disturbing the exact insulator or without affecting the clearances from the metal to the cap or on the creepage length, bringing down the creepage length. So, and also to see that the bulk stress which from the insulator is not deteriorated, particularly the whatever the additional fittings which is to be done should not create an issue for the corona inception voltage, or it should also be the mechanically fixed to this insulator where it could have a better solution for this conditions. So, here initially for this theoretical code was written based on the surface charge simulation method. This is again a numerical technique which was employed for simulation of both electric field, bulk stress and the electric potential across various insulators which are being used in the country, various ceramic insulators up to 765 kV systems, 800 kV systems. So, various insulator configurations have been taken, exact dimensions have been considered and the code was developed here, and for this a preliminary experimentation has also been carried out. So, the establishment of the facility at the institute was done particularly to see the improvements in the pollution flashover strength. So, the development of this information particularly for the polluted conditions to see that the improving the flashover strength of the existing insulator, and later this particular technology could also be used during the manufacturing time. So, this is with this lot of effort has been done, and both theoretical simulations as well as the experimental investigations were carried out as mentioned. Several insulators, you can see various insulators which are used in the country for the high voltage and extra high voltage, ultra high voltage transmission with various disc diameters, disc heights and creepage lengths are given here. So, which are used for 220 kV to 800 kV systems. These insulators were evaluated, and field reduction electrode or a field control electrode which it is known is being developed. This is a small gadget where it is also patented. So, this gadget can help which will be fixed near the pin junction here. So, this will only take a very small portion of the cement junction, that is the creepage is not disturbed. So, very little creepage is being used, the cement junction which does not form a creepage. So, the disc is fixed here, this is a metallic disc where the field is intentionally seen that it is distributed, and once the surface area is more, the scintillations or the partial arcs which are occurring gets reduced. So, this is the intention of doing that. So, suitable countering of this electrode is also very important, else the corona could start from the edges. So, very important, we have tried to see that the countering of this electrode has been done, and it has been placed for all the insulators. Various types of these electrodes have been designed and tried for the performance. So, here the simulation as well as the experimentation has been carried out. As mentioned, the simulation has been carried out using the surface charge simulation method for various voltage levels, and we have tried to see that the field and the potential is distributed, and particularly the field gets reduced when using the this field control electrode which has been mentioned. So, the potential distribution here in case of the 400 kV transmission system is simulated, where the field here is the equipotential lines which are being shown. Similarly, we show here the bulk stress or the volume stress which insulator sees. You can see the volume stress is very high near the line junction, that is a line end, that is a conductor, high voltage conductor end, slowly gets reduced towards the ground end. Here the potential is very high near the ground end. So, this bulk stress which is very high could be very dangerous over a period of time. So, it has to be reduced so that proper functioning of the insulator could happen. So, various options I told you, various type of insulators. So, these are various insulators for normal conditions, anti-fog, similarly for a very high creepage length insulators. So, several of these insulators, both theoretical as well as experimentation has been performed. You can very clearly see this blue curve shows the performance of the electric field near the pin junction for the conditions without any electrode. The red curve shows the performance with the electrode or with the field reduction electrode. You can very clearly see the reduction in the field near the pin junction. Example here, it is reduced by more than 50%. So, this is a very important point to be considered. Once the field gets reduced, the partial arcs or scintillations happening are reduced or completely eliminated, because at this working voltage, if the arcs or the scintillations do not happen, the flashover phenomena could be arrested. So, that is the intention of this. So, we have carried out various simulation studies for different insulators as mentioned, 10 different insulators conducted for used for various voltage levels, you can see in most of all the cases the field gets reduced drastically by using the field reduction electrode or field with electrode. So, this is a very important, this gives an encouragement to conduct some experiments in the laboratory and similarly find the performance using the lab in the lab. So, for this a facility was developed for testing the pollution or a contamination, wherein the source limitation we have is 150 kV, the current rating is 6 amps, where we can use up to 132 kV system. So, we have tried to conduct the experiments on single disc or a few discs in a string as the limitation of the setup. So, experimentation has been conducted with the available standards IEC 50600 507, which clearly gives the information about the contamination, how the insulators are to be contaminated or polluted. So, in accordance with this procedure followed in the IEC, so experiments were also conducted for normal conditions and for the insulators with the field control electrode fixed to them. So, here two types of experiments were done, one is by the dipping method, other is by the spraying method. Both methods have been tried out and the performance of all the type of insulators, single disc and also discs in 3 to 6 as the limitation of the equipment was is done. So, the experiments were performed. So, various experiments withstand the flashover of a single disc, 3 discs were conducted. And during the period leakage currents were also tried to measure with and without the field reduction electrodes. So, you can see in one of the case where the leakage current has also reduced drastically with employing the field control electrode. So, this string when you compare, this is the string without the field reduction electrodes, this is the string with field reduction electrodes. The leakage current what you see here when the voltage is applied 18 kilovolts, the current was 12 milliamps. Similarly, you can see here for the 20 kV, that is 20 kilovolts is applied to the string with electrodes, the current is only 10 milliamps. So, this shows with the field reduction electrodes the current also leakage current is also drastically reduced and the performance you can see the discharges which are seen early in a lesser voltage are reduced to an extent here. So, again several experimentation both for single discs, 3 discs in a string, 6 discs in a string were tried out with and without the field electrodes. You can see that the string which does not have the field control electrodes do not flash over, whereas the other flashes early. These experiments have shown that there is better performance in using the field control electrode. So, several trials were carried out and this technology is available wherein the pollution particularly for any of the ceramic disc electrodes could be these electrodes could be used for any of the ceramic discs which are being used for EHV and UHV transmission levels. So, this is about the pollution performance, and important is the mitigation techniques which are being used in the field and also the technique which has been developed at the institute where this will be very useful for the ceramic industry or manufacturers. With this I will conclude. We will look into the failures or the conditions in case what does it happen in case the insulator strings in a string some of the faulty insulators are there, how to estimate this field and potential, what could be the reason and how to take a decision pertaining whether this insulator should be changed or the condition for the utility engineers. So, this we will try to discuss what happens in case there are faulty discs in a string and how the potential and electric field gets distributed with the faulty insulators. So, thank you.